Alright, on this one we're going to cover area under the curve. This is topic 57, so let me get my pens here. Okay, so on this one, they're asking you to use 4 rectangles to find 2 different approximations of the area of the region lying between the graph of f of x equals x squared, this is the x squared line, and the x-axis, meaning this line. Alright, between 0 and 1. So we're going to begin by dividing into 4 equal parts. Notice that that's what we have here already. We have 4 equal parts. This is going to be 1/4, 1/2, 3/4. Alright, so again, you have your 4 equal parts right there. And we're going to start off by using the left endpoints. Alright, so this is actually, it can be a little bit confusing. You can do it any way you want to. If you feel more comfortable with it another way, that's fine. But the way I like to do it is I like to start drawing lines up to this graph. Now, because we're looking for the left endpoint, I'm actually not going to draw a line here because that would be the right endpoint of 1. So I'm not going to do that. So the first rectangle, if you notice, that the height would be 0 because it would be right here. The second one, though, I would just go straight from here to here. Okay, and the next one I would go like this, and I would just make this one join up with this one here. So again, one more time, that's how you do it. Now notice that you have a little point right here. Notice that I'm touching this rectangles. The left side of the rectangle is touching the x squared function. Alright, so to find the area, okay, what we're going to do, remember that the area of a rectangle is just base times height, right? So the area is going to be equal to, notice that all the widths of all of these, or it's going to be 1/4, right? And the height of each one of these rectangles, well, you can find that by plugging in this x value into x squared to find that, right? So the height of these, well, that depends. So we're going to say that this is going to be 1/4 times f of x, where if you input x values into f of x equals x squared to obtain height. Alright, so one more time, to figure out the height of this rectangle, so all you have to do is find the y-coordinate of that point. And the y-coordinate of that point can be found by plugging in each x value into the function, which in this case is x squared. So, okay, let's go ahead and find this. So we're going to use this notation, which means this is the left endpoint, alright, and we're going to have 4 equal parts, so that's why we put that 4 there. And then we're going to find the area of each one. Alright, so we have 1/4. Now, the first left endpoint is actually located right here. Alright, so the height of this one is actually going to be 0. Okay, of this rectangle, there really is no rectangle, but this rectangle right here, the height would be 0. Okay, the other one, well, we have the same thing, the length of the base, if you will, or the width is 1/4. And we're going to multiply that times, well, to figure out the y-coordinate right here, remember we're looking at the height of this little rectangle, well, the height is going to be 1/4 squared, and we're only squaring that because the function happens to be y equals x squared. Alright, now for the next couple is the same thing. We have 1/4. The height of this rectangle right here would be, well, that would be 1/2 squared, which would be 1/4. And then finally, the height of this rectangle right here, that's going to be 3/4 squared. So that's going to be 1/4 times 9/16. Okay. Now, if we kind of simplify this, we would find that this would be 1/4, and notice that I'm factoring out a 1/4 here. We have 0 plus 1/16 plus 1/4 plus 9/16. And that would give you 1/4 times 14 over 16. That's equal to 7 over 32, which is approximately, now of course I've used my calculator already, and I find out that this is going to be 0.219. And if you look at it, if I'm trying to approximate the area under this curve by using this rectangles with the left point, using the left endpoint, then the area, I'm going to underestimate this because this area is not going to cover all of it. Alright, so we're going to say that this is an underestimate. Okay, now we're going to do exactly the same thing we did here on the second one, and hopefully you finish copying that, but if not, just pause it and copy that down. Now for the second one, we're going to use the right endpoint. So we're going to do exactly the same thing. How I start this is the same way, except for now I'm going to include this one because this is going to be the right endpoint. Alright, so this is going to be the right endpoint. So I'm going to go up to this one, except for now, notice that I'm going to be touching the right endpoint. Okay. Now the next one, same thing. Remember, I have to, these are my right endpoints right here. Okay. So on this one, I actually have to go above this line and touch the right endpoint. And finally, on this last one, we have the same thing. Okay. Okay. Now there's actually another point right here. Okay, and that's going to be another right endpoint. Notice that there is going to be an area of a rectangle. There's going to be a tiny little rectangle right here. So I want you to be aware of that. Okay, so on this one, let's see. We're going to start off by same thing. We have the area of a rectangle. It's going to be base times height. So the area is equal to 1/4 times f of x. Right, this r stands for the right endpoint, and we're going to have 1/4. Right, notice that now though, however, we have 4 rectangles, of which, oh, I didn't graph this correctly here. You have a little tiny rectangle right here, right, unlike that other one. So we have a little tiny rectangle right there. So we have all the heights. Well, to find this heights, we're going to use the same thing that we used in the previous problem. We're just going to be squaring each one of the x coordinates. So this is going to be 1/16. If I square the 1/2, I get 1/4. And remember, all of these are the heights. Alright, so I'm taking previous knowledge from the last problem and I'm using it right now to make this problem shorter. Right, and if you look at this points right here, or this heights, and these heights are almost exactly the same, except for I moved to the right one spot, if you will. So notice that on this one I started with a 0, and on this one I started with a 1/16. Okay, so notice that I'm just moving right. And so after that, if we do this math here, we have 1/4 times 30 over 16, and that's going to be equal to 15 over 32. Now if we look at this, we can easily tell that this is going to be an overestimation because these rectangles are going past that curve. Okay, so the 0.469 is an overestimate. Okay, and we're going to take this idea further later on in this class, but for today that's all we're going to talk about. So let's go to the back of this. There's not a whole lot to say on the back other than what you just did. It's called Riemann sums. Alright, so on Riemann sums, basically this is the formula that you had here. Alright, except for they kind of wrote this backwards, or I wrote it backwards originally. This would be the height. Remember, that's f of x. And this right here would be the width of the base which is the change of x. Alright, so this is called a Riemann sum. So anytime you see something like this, it's called a Riemann sum. Now the n stands for the number of intervals. So if I tell you, for example, in this one, if you look at it, we have two intervals. We have, I don't know what you want to call this. Let's call this 2 and let's call this 4. All right, so we have two intervals. So in this one, for example, this would be, n would be equal to 2. Now to find delta x, which you can kind of tell that it's going to be 1 here just by looking at it if this is 3. But let's say that you don't know that, right? Because we don't want to draw the graph if we don't have to. So what we're going to do here is we're going to graph b, which in this case I call 4, which is right there, and then we have minus a, which in this case is 2, and we're going to divide that by 2, which is this number of intervals, all right, and that's going to give you 1. Okay. Now let's go over some basics here. If the function is increasing, like the last two examples that we just finished, both of those were increasing, and it's asking you if the function is increasing, which is the largest, the left or the right sum. Well, hopefully you notice that the right sum is going to be the largest. All right, so the right, if it's increasing, the right sum is going to be the biggest one. Okay. Now if a function is decreasing, then the left sum is actually the largest. All right, so let me just draw a quick little picture here. So if you had something like this, I don't know, something like, let's just start here and we're going like that, so we're decreasing, this function is decreasing, and notice that, for example, if this right here, and that's not a great picture, but notice that because my area is going to be above the curve, that's going to be the largest. So in this one, the left sum, if a function is decreasing, the left sum is going to be the largest. Alright, and finally, the one that's kind of a pain in the butt here is the midpoint value sum. So this is actually a better estimate because you're estimating it at the halfway point of those rectangles, so it's going to give you a better approximation. Now that's going to require a little bit more work, and so let's look at a couple of examples here, or one example that has all three sums. Alright, so they want you to sketch the graph and calculate the left, right, and the midpoint of the Riemann sum. So if you don't remember what this looks like, you can look at your calculator, I suppose. But it basically looks like this, or one side between 0 and 2, that's what it's going to look like. It's going to look like that. And I'm probably going to switch to pencil here because it could be difficult here. So notice that, for example, we know that they want to know, or we need to figure out our delta x. Now if you remember from the last page, delta x, which is going to be the width of our rectangle, is going to be b over a over n, where n is the number of intervals. Now the n, they're telling you they want 2 intervals. Okay, so delta x in this case is going to be equal to 2 minus 1 over 2, which is going to give you 1/2. Alright, so the widths of those rectangles are going to be equal to 1/2. And now we're going to go between 1 and 2. So let's say that 1 was right here. I don't know, let's say that I know that at least the first, if x is 1, y is 1, at least I know that much. Alright, and this is again 1, and I'm going to go by halves, so the next point would be 3/2. Then I'm going to add a half to this, so the next one's going to be 2. Okay, so on this one I'm going to be doing the left sum. So again, start from 1 and start drawing your, alright, so notice that I did the left sum here. And just make sure that your the left endpoint of the rectangle is touching the curve. So in this one right here, this one's kind of a difficult to graph here, but there you go, that's what it is. Again, make sure you're touching the left endpoint of your rectangle. Alright, the left endpoint of your rectangle needs to be touching the curve. So, alright, to figure this out then the left sum is going to be equal to delta x, which is 1/2 times the width of each one of these. Now, we know that the width of this rectangles are not going to change, so we're going to write it like this. So to figure out the height, that would be f of 1 and f of 3/2. So just like we did on that last example, the very first example we did, except for now the height of the rectangles are going to be decided by this function, y is equal to 1 over x. So that's going to be equal to 1/2. Now if I plug in a 1 into here, I'm going to get 1 over 1, so the height of this one's easy. This is 1. Now the height of this one right here, which is going to be 3/2 here if you look at it. Okay, 3/2. I'm going to plug in 1 over 3/2 is going to give me 2/3. Okay, and well, let me see what that is, because I actually didn't do it ahead of time. So we got 0.5, let me erase all that, 0.5 times 1 plus 2 divided by 3. Okay, looks like 0.8, let's see, what, 5 over 6, which is approximately 0.833. Now let's leave it like that. Right, and remember that this is going to be, in this case, this is an overestimation. Alright, so on the right one, we're going to do the same thing. Alright, same graph. We have 1 here, and let's call this 1 here. Okay. Now this one's going to be a little bit different. The change is going to be the same. Delta x is going to be the same, but now we're looking for the right endpoint. So I'm looking for that point, and I'm looking for this point. Alright, so again, this graph is not the greatest. Yeah. Let me show you one that I actually drew a little bit better than that earlier. So if that doesn't make sense, that's what it's going to look like, more or less. Okay? So on this one is the same thing. We have the right sum, and remember that 2 that just represents 2 intervals. Okay, we have this is equal to 1/2 times f of, remember that the right endpoint, okay, on this one is 3/2, and the right endpoint of this one is just going to be f of 2. And same thing, if you want to figure out what these are, just plug it back in into y is equal to 1 over x. So this is going to give us 2/3 here, plus 1/2. So this is equal to 1/2, 2/3 plus 1/2. Oh, I'm sorry, I'm an idiot. I'm just copying randomly now. So that's equal to 7 over 12, which is approximately 0.583. And it looks like I did this right, hopefully, because this is going to be an underestimation here, underestimating this. Now I found the midpoint. Now the midpoint is going to require a little bit more work. Now, before I draw this, I think what I'm going to do, again, this will be the midpoint, and we know the height, the width of each rectangle is going to be 1/2. So to do that, you actually have to be either really good at fractions or at least know what a tape measure looks like. Okay, so we have same thing. Let me see if I can draw this a little bit better this time. Maybe perhaps a little bit of a steeper curve. So we have 1, 3/2, and 2. Now on this one, basically what we're trying to find is the midpoint. Okay, so would be that point right there. Okay, so that's what we're looking for. Now to find those points, you're going to have to find the midpoint between 1 and 1.5. So if you can't do that, obviously you can, have 3 halves, and you can do the midpoint formula. So actually, no, you can't just find the midpoint of that. So the point that's in between 1 and 1/2 is actually 5/4. And that point right there, the point between 1/2 and 2 is 7/4. All right? So this is 5/4 plus f of 7/4. This is 1/2. This is 4/5 plus 4/7. Now remember that those came from me plugging in 5/4 into f of x is equal to 1/x, and same thing for this one. Okay, so that's going to give me 24/35. Now this is going to be a better approximation for sure. 0.686. Alright, so that's it, guys. Sorry that it took so long, but hopefully we can build on this, and the next few lessons should be shorter. I'm going to post a video of the homework next, so if you got any questions, take a look at that video first, and we'll talk to you later.